Zoex.net. Lesson 2. Color Specifications. Color specifications are the most prominent component of CSS styles. They are also the most commonly used styling property, so we want to cover the topic completely. To that end, we will explain all the different methods by which we can specify a color. We have used color names already, but these are most useful when we want to set a color quickly and we do not care too much about being precise. To access the full range of colors, we need to use one of the other methods for specifying color. The oldest of these other methods is the hexadecimal color specification. To understand it, it is necessary to understand hexadecimal. Hexadecimal is an alternative form for representing numbers. Ordinary numbers are called decimal because each digit can have 10 different possible values, 0 through 9. In hexadecimal, each digit can have 16 different values, 0 through 9, as we have in decimal, and A through F. The digits A through F represent the values 10 through 15 respectively. So each hexadecimal digit has a value 0 through F, which represent the values 0 through 15. For colors, we use a 2-digit hexadecimal specification. The first digit represents a multiple of 16, much like it represents a multiple of 10 in decimal. The highest 2-digit hexadecimal number is FF, which is 15 times 16 plus 15, or 255. For example, the value A3 in hexadecimal is 10 times 16 plus 3, which equals 163. With 2 hexadecimal digits, we can represent the values 0 through 255, or 256 different values. In the hexadecimal specification, 3 sets of 2 digits represent a color. The first 2 digits represent the red value, the second 2 digits represent the green value, and the third 2 digits represent the blue value. Colors on a screen are represented in exactly this way. They are made up of red, green, and blue, which are mixed to generate every color that can be displayed. All of the named colors have a hexadecimal equivalent that you can find in our CSS color names table. For example, here we have 3 overlapping boxes that are colored red, green, and blue via color names. Alternatively, we can use the 3 hexadecimal representations that we have in this example. Notice that the color specified as green has a green channel value of 8 times 16, which equals 128, while the red and blue have channels with the values 255. They specify green with a lower value because our eyes are much more sensitive to green than red and blue. So a green value of 255 is much brighter than the same value in red or blue. This covers the named colors and the hexadecimal specifications. Next, we will look at the RGB specification. RGB is similar to hexadecimal, but it is easier for those who do not know hexadecimal. For the RGB specification, we write RGB with a comma-delimited list of 3 values that represent the red, green, and blue channels of the color with decimal numbers between 0 and 255. Here we see the same red, green, and blue specified as RGB. Again, the green channel of the green color is only 128. The RGB specification has an RGBA variant. RGBA stands for red, green, blue, and alpha. Alpha is the 4th component, and it specifies the level of transparency. Unlike the color channels that are integers from 0 to 255, the alpha values run from 0 to 1 and are generally not integers. To illustrate, here are the RGB specifications alongside the RGBA specifications with an alpha value of 0.5 or 1/2. Notice that the transparency allows the colors to show through each other. This is how alpha works. An alpha value of 1 is considered opaque, which is how normal colors are displayed. An alpha value of 0 is totally transparent, which means that it cannot be seen. Values in between are semi-transparent, like the 0.5 that we used. Our last specification is the HSL specification. HSL looks similar to RGB, but the values represent hue, saturation, and lightness. The first component of the HSL is hue. It is the value from 0 to 360, with 0 being red, 120 being green, and 240 being blue. The saturation specifies how dull or vibrant a color is, and the lightness specifies how bright or dark it is. The saturation and lightness values run from 0 to 100%. HSL is not commonly used, but it is good to see it so that you understand it when you see it used. To help you understand these values, I animated them in CSS. The first block varies the hue to show you how it varies as it runs through the values 0 to 360. The second varies the saturation. Notice that the block goes from bright red to gray. The third varies the lightness, going from black to white, with the middle value being red. Like RGB, HSL has a variant with an alpha channel, HSLA. Here we show 3 different HSL values and the same values with an alpha value of 0.5 as before. The hues are red, green, and blue with different saturation and lightness values. This should give you a further indication of how HSL works.